Okay, before we get started, I would recommend that you go to the video description and you'll have the GitHub link for the documentation we're going through. I generally design these as a stepwise process where we can go through these together. And so this is video one of the Kubernetes in the Cloud series, and we're going to look at Amazon's Kubernetes offering, which is Elastic Kubernetes Service. And it complements a couple of videos that we've done before. One, we did AWS autoscaling, and in that we had this Flask microservice that just talked to a simple database, stored some names, got it in and out, and we deployed it with autoscaling on VMs. And that was kind of heavy-handed because these microservices are they're small. And so we did another video, which is we containerized the exact same code and deployed it with AWS App Runner, the simplest container runtime in AWS. But in both cases, we use the same code. It uses the Flask framework and talks to DynamoDB. So this is going to be a fully automated deployment of that same microservices and some web content that we also add with Amazon EKS. And we have all the Terraform and shell scripting to build it and deploy it. And so what we're going to build in this project together is we're going to build an Amazon DynamoDB database. That's what talks to the microservice to store data. Then we're going to build a Docker container that takes that Flask code, builds it with Docker, so we can use it in EKS. Then we also have 3 additional containers that we're going to build. And these are cool little games that I found, and there's the references here. And they're just JavaScript names, Tetris, Frogger, and Breakout. It's essentially pure HTML content. And we're going to package that up in 3 containers. So end up with 4 containers total. And we're going to push those containers into an Elastic Container Registry. We end up with 2 container registries, one for the Flask app and one for the games. Then after we do that, we're going to deploy EKS. This takes the longest. It takes about 15 to 20 minutes to deploy EKS. And then once that's deployed, we're going to glue up kubectl so that we can deploy some Kubernetes manifests, some YAML essentially, that deploys all of the containers as services and deployments, and then an ingress for them. And then finally, we use NGINX paired with an AWS load balancer, and that gives us an endpoint, and then we can go to different paths on the endpoints to invoke the games versus the Flask app. So that's what we're going to build in this project. And so let's talk a little bit about the nature of EKS. And I put forth is EKS platform as a service or infrastructure as a service. And it's a little confusing at first because it is a platform as a service, but one thing that makes it different than other platform as a service is it provisions infrastructure on your behalf to implement your Kubernetes cluster, but it does it transparently. So you can go look in your account and you can see all this infrastructure that gets provisioned that's associated with EKS. So let's go through sort of the elements of EKS and what infrastructure gets provisioned for this solution. So let's start with the control plane. This is the management layer of Kubernetes. Now, we don't know how it's implemented because it's fully managed and abstracted. So I assume it's EC2s, maybe it's containerized itself. But this does all the orchestration between the other services. So this one is the part that's really classic PaaS. It's totally managed. You don't get to see how they're doing it, and you just get interfaces that you can call. So then we get into Kubernetes when it provisions nodes. And in EKS, they're called node groups, which are a little different than the other platforms. They call it node pools, but they're really the same thing. And so when you provision a node group, and we're going to do 2 in this, you describe what you want in the node group, the min, max, also the instance types, and any autoscaling behavior. And what it does is when you declare them, it goes and creates autoscaling groups that implement those node groups. And so what you're going to end up with in this project is you're going to have 2 autoscaling groups, one for the games and one for the Flask app. And one of them has 1 node, and only 1 node, and the other one flexes between 1 and 4. So you don't provision it, but you describe it, and it provisions on your behalf. Then you've got load balancing. Same thing. When you go and Kubernetes say, give me a load balancer, give me a service connected to an Ingress, it's going to automatically provision an elastic load balancer. I say automatically provision elastic load balancer. That's not quite true. We had to do some extra steps because the default load balancer with EKS is the classic load balancer, which I thought went out of support like 3 years ago. But in any event, there is a Helm chart that we run that installs the correct load balancer. So we end up using a network load balancer in this scenario, a level 4 load balancer. Now, one of the things we're going to do is we're going to look at the infrastructure that gets provisions. And what we're going to see is we've got all this tagging. The nodes, the auto scaling, the load balancer, the target groups, all the pieces and parts that make up this EKS cluster. The bookkeeping, the glue that allows EKS to keep track of what parts it's using is in tags. So you'll see all sorts of tags. AWS does this for auto scaling too, so it's not too terribly unusual. But I guess the downside is you can see all these tags. So potentially, with all the stuff, you could go in, mess the tags up, really change things that would impact the system, and there's nothing to prevent you from doing that. So it's sort of a double-edged sword. It also gives you the ability to customize everything. So that is the cost benefit. You can do anything you want with the customizing the infrastructure, but you could shoot yourself in the foot if you don't know what you're doing. Even if you do know what you're doing, it's generally you want to let EKS manage this infrastructure and not try to do that. So again, it's EKS is platform as a service, but it's unique in that the infrastructure it provisions to implement the service are transparent and you can interact with it. Compare this to something like RDS or Managed Microsoft AD. And both of those, the system or the cloud provider is going to provision EC2s to actually implement that, the domain controllers, like a Postgres server, those types of things. But you don't get to see the EC2 instance. You can't go in the infrastructure and see your domain controllers as EC2s. And same with the databases. Like the databases, if you do, global readers and other features of RDS, and it's going to provision additional resources, you don't get to see them. You just get to interact with them from the abstraction layer. So that's where this is a bit different. Okay, so now let's look at the EKS solution we're going to build. And I guess I go to the diagram. And the diagram for the EKS, AKS, and Google Cloud are remarkably similar. So this is, the sort of the abstract layer of EKS. So you've got the control plane. That's the part that we really don't know how they implemented it. Probably EC2s is extracted, fully managed. Now, in our example, we're going to connect kubectl into the control plane. So that's how we're going to interact with the cluster. That's our main interface. And then we end up defining a Flask app node group where we're going to put the Flask app APIs. And then a games node group where we're going to put the games, let's say HTML content. So in our YAML, we'll tag which nodes these should go on by the node selector. And then we have some connected services. The first one is VPC networking. We're running in a VPC. You also were connected to the ECR, Elastic Container Registry. We have to grant permission so the cluster can talk to it. DynamoDB, we have to create a Kubernetes service account or a Kubernetes account that it can interact with the DynamoDB and attach it to these nodes, and that's all done through the YAML along with some Terraform code. Then we have the Elastic Load Balancer. That ends up being a network load balancer in this case, and that is paired with NGINX services to do the path mapping. That, okay, this path goes to the games, this path goes to the API. So that's sort of the abstraction, and again, this looks very consistent across all the cloud providers. Where it gets interesting is, what did it actually go and provision on your behalf? And that's where we get into what we talked about earlier with the platform as a service versus infrastructure. So we got our VPC, we're in US East 2, and for the Flask app we have an autoscaler group, and it balances between two private subnets. Then we have an autoscaling group for game nodes. Now there's only one, it's 111 for desired min max. So there's only one here, but it still manages as an autoscaling group. So it's very consistent the way it does that. Then we have the network load balancer that gets provisioned. And it's not a load balancer that's connected to autoscaling or connected to EC2s. It's a load balancer that's done by IPs, and that's because the control plane is going to attach different routes into the Kubernetes cluster, like basically different pods that are running to the network load balancer by IP address. Then outside of our VPC, we've got the DynamoDB table when we have the two ECR registries, the Flask app and the games. So now let's talk about the prerequisites before we do the build. Now there is an AWS and Terraform easy setup that it can walk you through all these steps, but here's basically we're going to need an AWS account. We're going to have to install the AWS CLI, the latest Terraform, then we need Postman, and then we need Docker to build the Docker containers. I'm assuming this is going to be run on a Linux variant, so I'm going to show you an Ubuntu build environment. But at this point, I'm assuming that you have done all of these and we're ready to build. Okay, so what you want to do is you want to go copy this code right here and go to our development environment and do paste that in. And now we've got the project. So the first thing we want to do is we want to run check env, which is going to check and make sure that you have all those prerequisites installed. So it goes, it checks all the things, it actually logs into AWS CLI for you, and now you're ready to go. So at this point, what you're going to do is run the apply, which is going to run the build, and we will talk briefly about how the build works. So the build really has 4 phases. The first one is we provision the ECR repositories and the VPC. So it runs relatively quick, that first phase, and it builds those 2 ECR repositories and then sets up the VPC. Then the next part of it is we're going to just use build Docker to build all the containers, the Flask microservice and the JavaScript game apps, all 4 of them, all 4 of the containers. And as it builds each one, it's going to push it into the ECR repository. That's phase 2. Now phase 3 is we're going to provision the Amazon EKS cluster. This is the one that takes the longest. It does the control plane. We've got the Flask nodes, the game nodes. This takes about 15 minutes. And then after that, we connect to the cluster via shell script to connect to kubectl. We glue kubectl to our EKS cluster. And then we have 2 YAML files that we're going to run. That's going to run the Flask app. It's going to define it on /flask-app. And then the games are going to be defined on /games. So at this point, we are ready to wait for the build to finish. And we'll come back when that's done. Okay, the build has completed. So now let's bring up the console and take a look at both the Kubernetes cluster that got created and also the infrastructure that we were talking about earlier. So I will bring up the console and a web browser. And the first thing I'll do is click on EKS, Elastic Kubernetes Service. You can put it up at the top, but click on that. And you will see the Flask app container running 1.3.2, which I believe is the latest, and that's good for another year. At the end, we'll talk about the support cycles. Then let's click on that. We've got the overview, which is how you interact with the control plane with the OIDC URL. And we have to have the right certificate authority. That's all stuff that gets glued up for you when you run the AWS CLI to connect your EKS cluster to kubectl. So you don't need to worry about using this directly. Then we've got this nice resources tab. And this resources tab is essentially a web interface into kubectl. So pods, I'm going to switch to the default namespace, and you'll see the Flask app pods running. And then I can click on to the games, and you'll see Breakout, Frogger, and Tetris. Let's see here, and then deployments. same deal. There's the games deployments, and then the default, the Flask app deployments. There's two pods for that deployment, so it scales at that level. And then from the cluster, you can see your nodes. Those are the two nodes, and where else was it? The namespaces, which has got default and games, and then all the internal ones like Ingress, NGINX, stuff like that. So that's it for this sort of kubectl interface. Then we've got the compute node, or the compute tab. And in there, you get all the nodes. There's currently one or two nodes running, and they're T3 medium instance types, and one's in the Flask nodes group and one in the game nodes group. And then the node groups are here, and that'll give you more information on the node groups. So let's go back to the EKS cluster. Then we have the networking, which you can see is attached to your VPC. It's connected to subnets, and it allows everything open at this point. It's a public API server. You would not normally do that, or at least I've never had anything Kubernetes with the public endpoints being there, but this is just what we did for this particular exercise, just to make it easy for us to interact with the Kubernetes cluster. Okay, that's pretty much it from the EKS cluster there. We got the tags, and we'll look at the other ones. But the other thing is that we build is the ECR, the Elastic Container Registries. And hello, here's my repository. So we got the Flask app and the games, and that's where we're pushing our containers in, and that's where we're pulling them when we're deployed with kubectl. So that's it for the mainline EKS. So let's look at the infrastructure, what we were talking about before. Infrastructure that gets provisions on your behalf. So let's go to the EC2 element in the console. And let's look at autoscaling groups. And you will see two autoscaling groups that get created, each for the different node groups. So we've got Flask node groups and game node groups. It puts a bunch of unique identifiers in there. Well, if we go in there, you can see that it's just sort of a standard autoscaling group. It's got 1 to 4. There's a launch template, which it manages for you. There's the number of instances, and we've got that. And then let's go back to details, and let's look at the tags. So if you look at the tags, you can see we're already seeing these K8 cluster nodes. Everything's tagged, and it gets even more interesting when you click on one of the instances for the nodes and click on that. And look at the tags. It's got a lot of things in here. Some of it is related to autoscaling. Some of them is going to EKS. So you can see how tagging is used extensively to sort of do the bookkeeping. And it's the same thing with if I go to load balancers. We should have the Kubernetes load balancer that's connected to NGINX. You click on that, and tags. It's not quite as many as the other ones, but these are all the tags that keep things, the bookkeeping associated with it. So I think I've covered the instances, the load balancers, the autoscaling groups. I think it's now we're ready to actually test the application endpoints. So let's go back into our documentation and find the endpoints. So here's the endpoint summary, and what I'll do is I will start Postman, and the first thing I'll do is go in here and say validate. Make sure this thing is still running, but more importantly, get this URL. Alright, so we're going to copy this URL in here. We're going to go to Postman. We're going to put it in here and hit send, and you're going to get the same sort of thing you got in the other exercises. We can also go and do candidates. And you can see there's one, and then I can do a post and say candidate and say homie, hit send, and then go back to the Git and do candidates, and you can see it's got both of them. So this is the API, and notice the path, the Flask app API. So now let's copy this, and let's go back to the web browser and do a new tab. Right there, and it's going to say NGINX not found because you didn't use the right path. So now if I go and do games, Tetris, it's going to bring up that instance. Then I could also do Frogger. Haven't played that in a while. Hey, look at that. Then we have Breakout. And I will just lose this one. And so those are the 4 containers. You've got the Flask app, and then you have the games ones, and it's all the routing on the NGINX Ingress that controls which path in the URL gets mounted to which, or which gets routed to which container deployment. So that is the endpoints. Everything gets deployed. The next thing we're going to do is we're going to test scaling. So we've set this up to do auto scaling. So when it reaches too many resources, it'll scale up to 4 nodes for the Flask app. And so what I have is, let's do kubectl. Let's do a little kubectl to see if we can get the same views that we've got on the other one. So kubectl get pods. So those are the 2 Flask app running. And then I can do d namespace to games, and I'll see the games, and I can do kubectl get nodes, and you'll get the 2 nodes. And of course I could describe any of the stuff. So if I describe let's see, pod Flask app, oops, you see, this is, at this point you're in sort of a pure Kubernetes situation. And so yeah, there's things in here about the container but for the most part the YAML that we're using across all these projects are the same between the providers, other than the image ID. So we've got that, and so what I'm going to do is I am going to run, there's this YAML file in there called stress.yaml, and we're just going to overload the nodes with this high CPU reservation YAML, and that will cause the cluster to burst up. So let's do kubectl get I guess nodes. What we're going to do is do kubectl apply -f stress YAML. Now let's do kubectl get pods, and you can see there's several pending, and the reason it's pending, if I describe the pod, it's going to say, hey, I got nothing. There's no node to actually run. No, so it can't run. So the pod is triggered to scale up. So now what we need to do is just wait. So we'll go back to the AWS console, close this, and look at the autoscaling group and say details, instance management, and let it run. And actually it's already up. Okay, it's quite fast. It only took a couple of minutes. It went from pending to in service. So now it's bursted up to 4 nodes. So now if we go and go back to kubectl and say kubectl get pods, you'll notice the ones that were pending are now no longer pending. They're running. And if I do a kubectl get nodes, you can see I now have 5 nodes. We've got the 4 from the Flask apps node group, and then 1 from the games node group. So the opposite should happen now. If I do kubectl delete -f stress.yaml, now I do kubectl get nodes, and we have to do another one. Now it takes longer to scale down, which kind of makes sense because you don't want to preemptively scale down. So we'll wait a few minutes and you should wait a few minutes and let it scale down. Okay, after a few minutes, you will, if you do kubectl, actually just recall, get nodes, it bursts down back to 2. So that is pretty much it at this point. You could incorporate more YAML, pull like BusyBox and other examples just to see how the Kubernetes works in EKS. Um, but as usual, you want to be good stewards of your cloud accounts, and these services are not cheap. So there's a destroy thing, and so what we'll do is we'll run the destroy pipeline or the destroy script, and while that's running, we will talk about the AWS specifics Kubernetes issue. Well, the first one has to do with the VPC requirements for CIDR blocks. The thing you need to keep in mind, and this is true on all of them, is when you're budgeting a CIDR block and number of IP addresses, you need to keep in mind that Kubernetes allocates a IP address per pod. So when you're budgeting, if you have thousands of pods, even though you may have like a dozen EC2 instances, you're going to need 1,000 IP addresses. And this can often be, if you especially have something that's using a lot of pods, and if you're negotiating CIDR blocks, can be a kind of a tricky situation with a client where you're trying to get the biggest block and they don't want to give it to you. But you need to be mindful of that. I've rebuilt several clusters because we didn't budget enough. The nomenclature, AWS calls it a node group instead of a node pool on the other two providers. Not a big deal, but if you see node group, just node pool is the same thing with respect to the Kubernetes. All right, the default load balancer is kind of boneheaded. EKS, if you don't do anything, you hit a classic load balancer, which makes no sense because that went out of sport in 2022. So it's kind of like, why you even bother me with this? So you have to run a Helm chart to use the newest load balancer, and then I think there's annotations that tell you whether or not you're going to use a network load balancers or a application load balancer. In our example, we end up with the YAML that we uh, applied. We end up getting a level 4 load balancer, and so that's the solution that we get here. The other thing to keep in mind is auto-scaling does not work out of the box. The other providers, auto-scaling, the thing where we do is stress, where we bounce up and bounce back down. It doesn't do anything by default. You have to run a Helm chart that Amazon provides that will pull in the auto-scaling functionality. And then there has to be, I think, annotations on some subnets and stuff. But it's in the project. It's pretty easy to understand. It's just if you notice that, hey, it's not scaling up, you need to make sure that that Helm chart is installed. Finally, let's talk about EKS Kubernetes versions. This is true for all of them, but each version gets 14 months of mainline support. It's like 12 months and then two additional months. And then the service providers allow you to buy an extra one. And at the time of the video recording, for EKS, it's like 10 cents an hour for the control plane per cluster. And once you go into extended support, it goes to 60 cents. So it's a fairly significant increase, 6x. But that's usually not the control plane is not your most expensive thing. So if you compare it to like network surcharges when you move between data centers and some of the network storage, it's a fairly minor expense. But in any event, they give you that extra year. And I've read that if you don't upgrade after the end of that extra year, that they upgrade you. I have never seen that in practice, so I don't know how accurate that is. But if you're, working in a regulated industry like I'm in, these can be kind of a pain because validation of these systems are very expensive and can take months. So the idea that you probably want to upgrade at least every 14 months and maybe you can get an extra year flies in the face of a lot of deployments I've seen where we deploy something and really haven't changed it and it's just sitting there for 10 years. You can't do that with EKS. It's so much more agile and they're going to want you to upgrade. So I believe that's it for EKS, and the next two are going to be Azure Container or Azure Kubernetes Service, and then the OG GKE Google Kubernetes Engine.